when it comes to where you are, where you're standing, what you're standing on, do you have any ideas around that? Like, what do you think? What do you perceive? What do you experience?
I think it's quite spherical.
What you're standing on is quite spherical. What
Yeah,
leads you to believe that in your kind of everyday life, your experiences?
probably from what people who know more than this have told me. Well, no more than me have told me.
Okay, so it's not anything that you, as a thinking human being, experience per se. It's just a story you've been told, and you believe the
Uh,
story. Your everyday experience doesn't necessarily match that. Maybe it does, maybe it doesn't. I don't know. You could give me maybe an example of how your everyday experience would lead you to trust that story.
well, it's just I'm taking somebody who knows more than me and has spent more time on this subject than me his advice, like I do with everything in life.
Yeah, well, one of the things I do that earns me money is I'm an accountant, right?
Mm-hmm.
So you might trust me to be your accountant, but being an accountant, if I was not being a professional and not living up to the standards of the profession, I could probably figure out a way to swindle some money off you without you knowing, right?
Yeah, probably, but I'd say it's quite different than uh, making up scientific proof.
Oh, so you're under the impression there's some scientific proof of what exactly? Because a shape claim isn't really science, that's more measurement, right?
Well, I guess more everything kind of fits and works together, which is what a theory is, isn't it? System of belief.
So when you say everything fits and works together, are you under the impression that there's some sort of scientific model or some working model of what may be portrayed to you as the
Well,
earth and the universe?
Mm.
if you talking model, isn't that called the heliocentric model?
Yeah, but we got to
Yeah.
stop right there real quick before we continue. A scientific theory is not a systemized belief. A systemized belief is a religion. So if you're claiming that the globe is a system of beliefs, then you're basically saying it's a religion or a philosophy at best.
Well,
Continue.
kind of, but the definition of theory is a system of ideas intended to explain something.
Could
You get
religions
me?
be theories, right? Could we take any religion you want to pick, and could we say that that religion is a theory as to God, a creator, a prophet, certain theological beliefs?
Yeah, I guess that makes sense if it's a system of ideas. Yeah.
Fair point. The problem is we're now all confused because you
What do
were
you mean?
starting by talking about science, and then you use the word theory, and then you give a definition that it doesn't have to do with science. A
Well,
scientific theory is a specific thing, which is not the definition you gave or the explanation you gave.
isn't science like, I don't know how to explain it. It's like proof, isn't it? Do you get me? It's facts based on observation.
No.
What is science?
Okay. Science in the way in which we're using science in this arena, right? When people say there's scientific evidence of the globe, okay? Scientifically validated evidence is about cause and effect relationships that are validated by experimentation. Okay, so a theory in a scientific theory comes after an observation of the natural world, a phenomena that occurs within it, a hypothesis about if this occurs, then maybe it causes that phenomena, the effect. You then have a rigorous, hold on, you then have a rigorous experimental phase of validation that will either validate your hypothesis or nullify your hypothesis. Once all that is complete, then you can start having a scientific theory. So that being said, since you use the word science, where is any of that for the idea that the Earth is a globe?
Okay, so first of all, I apologize for saying science is. I mean, sorry, as far as a religion, it's a theory. I'd say it's more of a hypothesis, then, isn't it?
No.
Because if it's so with that, why is I'm a bit confused with that? Because like, wouldn't it be a hypothesis because it's what you think is happen, like what you think, but you haven't observed it yet.
Well,
It hasn't been
not in a
tested.
scientific sense.
Same thing you're talking about.
It's just an idea.
Yeah, exactly. Hypothesis.
Right, but you see, a hypothesis in regards to science is a specific thing. Just because it's the same word doesn't mean it's the same thing. You know, in
Oh, it's
general
an
common
idea.
language, yes. So in general common language, a hypothesis is just the underlying belief, right? Of why you hold a proposition to be true. That is not what a hypothesis is in the scientific method.
What is the hypothesis?
It's a specific if-then statement that's validatable. For example, if 180 degrees Fahrenheit applied to water, then water boils at sea level, right? And then you can validate that by demonstrating it. So, for example, let me give you an example of something that doesn't apply. Okay, there is a blue knife on my table, right? Not a scientific proposition. It simply is the case that there's a blue knife on my table.
Yeah, because you observed it.
Yes, directly. The object in question is directly observed. There's no causal relationships required, right? Now, I want you to ask me questions about my knife.
Okay.
So ask
There's
me
your knife.
questions about it.
What questions do you want about your knife? Is it sharp?
You think of the questions. You think of the questions that you would need to ask to divine what it is, because it is a knife of a certain type. So start asking questions like maybe the size of it.
Okay, how big is the knife?
7 inches long. Okay, stop. Don't continue. Did I need to do any science to get that answer?
You need to measure it.
Oh, there you go. All right. I pass it to my friend who was talking to you earlier.
Okay.
Is that my cue?
I think so.
You can take it, Napalm.
Sure. So, yeah, the measurement isn't science, right? Is that what we were just talking about?
Yeah.
I thought it was a part of science.
It's not. Measurement is just measuring something.
Yeah, it can be a tool used in science, but it wouldn't be science itself, right?
So it's to measure. I'm a bit confused. So it's part of science, but it's not scientific.
Yeah, so like AI was saying, in this realm, right, in this arena, we talk about science, natural science, which is the study of the natural world through experimentation, right? So we observed something in nature. We observe
Yep.
an effect, right? So let's go back to when he was talking about water and heat. So you and I are walking along and we come upon a boiling pool of water. And we've never seen this before. We look at it and we're like, oh, wow, this water's boiling. And then we come up upon it and we realize there's steam, and we kind of touch it briefly and we realize, oh man, this is hot. This feels exactly like the fire back where we came from. I'm wondering what's going on here, right? I feel heat within the water and I see it boil. So maybe we could form some sort of hypothesis as to why the water is boiling. Maybe it's because of the heat. So we go back to our campsite and we try this. We take some water, we put it over the fire, and it hits a certain temperature over time, and it starts to boil. So we can do this over and over again, and it's repeatable. So we have a variable that we're manipulating, which is the heat. We're putting the water on top of the heat, taking the water off the heat, stops boiling. So we're manipulating a variable that we think is the cause of the effect that we're seeing, which is the water boiling. So then we come to the scientific theory that heat causes water to boil. And we've demonstrated this through experimentation, right? So the key to all of this. Now, if we saw from a distance, really far off in the distance, a pool of water that seemed to be boiling, but we had no interaction with that pool of water, and we just started coming up with ideas as to what may cause that water to boil. If we don't touch that water, or we don't look at that water, or we don't try to take water ourselves and figure out what can cause this boiling, do any of our stories that we may come up with as to what is causing the water to boil, do you think any of those would be relevant?
It would be a hypothesis.
So let's say you have a hypothesis. So we're viewing this water that's boiling in a distance. We've never seen anything like this take place before. We're familiar with regular water. We've got some around us. What is your hypothesis as to why that water we see in the distance is boiling?
Because it's warm.
Let's come up with another hypothesis as to why water is boiling. We have no idea. We've never seen this take place. We would have no inkling or indication as to what may be the cause. Throw out an idea.
I have absolutely no idea why water would be boiling.
Well, we could maybe we could say that we think that there's some sort of entity or being that lives within this water that is somehow below the surface, which is causing this thing to take place, right?
Yeah.
Well, we'll make up a name for it. You pick the name.
It's unicorns.
Okay, so unicorns.
Read that in the chat, you copper. You want to cheat.
So our hypothesis is that we've got these unicorns, whatever these may be, that are underneath the water that are causing this agitation that we see that looks like little bubbles. Now, what would be the first thing we would do to test this hypothesis?
I would try and see if we can find these by ourselves. I'd try and observe one of these little unicorns.
Right. So we never experience these unicorns. We don't see them. We have no viable reason whatsoever to believe that, one, these unicorns even exist, and two, that we would have the ability to find them, and three, that maybe if they got in the water that they would cause this effect.
Rule that hypothesis out. It's not true. We cannot observe it.
Right, we haven't observed it. But if we have no other viable hypothesis, can we just claim that since that's our best hypothesis, that it must be true? Nobody else has come up with another one. You can't think of another one. Nobody has done any experiment with water to figure out what may cause it to do the thing that we're seeing off in the distance. But we have this postulation that it's unicorns. And then everybody starts to catch on to our story. We start talking around town. Yeah, that water off in the distance that we can't get to, but we see it and it boils. Yeah, it's these unicorns. Really? No, yeah. And then we start coming up with more stories about the unicorns, the color of their fur, how they can breathe underwater, all kinds of different things, right? Now, if we tell these stories, we tell these stories long enough and nobody ever actually touches the water, goes to the water, tries to do any experimentation whatsoever regarding the water, does that make our theory, because it's the only one that we have, a viable theory?
It's the right hypothesis. Well, I mean, it's the wrong opinion, but
we haven't proven
it's the wrong hypothesis,
right? Because we haven't done an experiment. That's the whole point. We need to do an experiment in order to come up with a viable hypothesis, right?
Or you could observe these unicorns.
So let me ask you a question. When it comes to what you believe in, the heliocentric model, globe Earth, all of this stuff, has any of it been scienced? Is any of it even a question of science? So it's been observed.
It's been observed.
Right. So what in particular has been observed?
Curvature.
Curvature's been observed. Where is this taking place?
What do you mean? I don't understand.
Where and who has seen curvature?
Every person that's, I can't remember the exact place. Every person that's ever seen an image or a video from above.
Every person that's watched TV.
Okay. So we got
every person that's seen an image or a video. Well, if you photograph one of these unicorns, you would have proven to see the unicorns there, and
Right. So you're under the impression. So you're under the impression that we have a photograph of Earth from space.
Seems quite likely to me.
Seems quite likely, but the funny thing is, it's 2022, and we still don't have one. Why is that?
I'm back.
Did you hear me? It's 2022 and we still don't have a photograph of the Earth from space. Why is that?
I don't believe you.
Where
Can you provide one to me, or have you seen one? Could you give me an idea of an image?
Blue marble.
All right. Blue marble 2.0. That's a picture of Earth from space? I'm sorry, what was that?
I believe so.
You believe so? Do you know so? Or do you believe so?
Doesn't seem very... It seems quite credible.
Seems quite credible. Okay, well, what if I told you if you go to the NASA website, you can find a data visualizer named Robert Simmons, who has also been interviewed on a radio show talking about how he created the blue marble image. So what he did is he took strips of high altitude pictures and took that flat map, wrapped it around a ball in Photoshop, and then started coloring it in. He put in the clouds. He talks about how he made the colorations within the oceans, how he made it a little bit more green in areas that they had sensors that sensed more phytoplankton in the sea. He decided to use that data to color those parts a little more green, right? So the interviewer even asks him, so there's artistry to making the Earth. And one quote that Robert Simmons has is that he says, it's Photoshop because it has to be.
I'm reading this.
Did you find Robert Simmons on the NASA website? You can read it all.
Yeah.
I'm not reading.
Yeah, while you're reading that, so you might say, oh, okay, that's not a photo. But the Himawari 8, that's a photo. And that came
no
after
idea
the
what
Blue
that is.
Marble. And
What
it's a
is that?
satellite. Right? So in the modern day, they put up a satellite called Himawari 8, so they say, with the intention of taking photographs, right? Because they realize nobody's buying their other fake nonsense that's not a real photograph. So lo and behold, people believe that the Himawari 8 is taking a photograph of the Earth every 10 minutes. Come to find out, the Himawari 8 is just overlaying the blue marble data set that Simmons created with NOAA data, which is weather data. So it's a simulation. It's not a photograph. So again, like my friend said, where's this alleged photograph that everyone has seen?
It says here that in 1972, during Apollo 17, that was the last time someone took a photograph from above low Earth orbit.
1972. That's the only alleged photograph.
From what this is saying, whenever this interview was out, 2004.
So it's 2022, and the only photograph that's ever been taken of the Earth from space is from 1972. Do you believe that?
From low Earth orbit, according so it shows the entire hemisphere.
It's from them. They were going to the moon, they claim, and that's when they claim to have taken the picture. But NASA admits today that they cannot cross through the Van Allen radiation belt. They would kill anyone who would try. So they cannot send people beyond low Earth orbit or to the moon.
What? So apparently,
so that's why they couldn't have taken that picture. And even if you watch the documentary, a funny thing happened on the way to the moon. The tapes from when they were faking that actually showed more and were leaked and found and were shown in that documentary. So you can see exactly how they faked that picture as well.
Right. So what we're telling you here, my friend, is that the only photograph that everybody's seen is scandalous at best, unvalidatable at worst. So again, where's this supposed photograph that everyone has seen?
According to what you said, there isn't one.
Oh, there you go. That's the answer.
Well, I find it hard to believe, which I'm sure is quite normal. Wait.
So you think it's rational to believe that the only legitimate photograph happened at the beginning of space exploration, and since then, not one has been duplicated by an advanced system? You think that's easier to believe than just to believe that they can't take a picture because they can't get far enough away to take a picture? Just like our other friend just told you, they admit that they're planning missions to go past low Earth orbit, past the Van Allen belts. It makes it sound like, wait a minute, didn't you already go past the Van Allen belts? I mean, if you're a wise person, my friend, and you think self-reflectively, all that sounds pretty scandalous, don't you think?
Well, I don't think we've really have people really been past low Earth orbit since the end of Apollo. No, not really.
No, they never
Because
went past it. They never went past it, my friend. That's the
Yes,
point.
yes.
allegedly,
What he's trying
according to NASA.
what he's trying to say is in the Orion project, that's NASA. They admit themselves, just like he said, that until they fix this problem of going past the Van Allen belts, they cannot go past low Earth orbit. We're using the globe experts, NASA. They're telling you the truth. They can't go past. That means they never went in 1969 to 72 ever. They never went.
What? So they said they went, but then they said, for some reason, I don't think they do that.
Yeah, they said they went a long time ago, and then they realized, oh, the radiation would actually be completely lethal and can kill anyone who actually tries. So that's why anyone now cannot go. And for the last few decades, no one has been allowed to go because it's deadly. You can't go. It'll kill you. We don't have any shielding that'll protect us, so we can't go. That's their excuse right now.
All right, fair. However, the pace is getting too frenetic. Okay?
Right.
People are interrupting each other, and that's causing people to create a fog of war in their mind that they have to talk faster, and it's just going to escalate. So I'll take a moment and breathe, and then continue.
So, Laundry,
Yes?
is this new information to you that the Blue Marble 2.0 is not an actual picture, right? The only claimed pictures from 72. And there's certainly some issues around whether any of those missions did or did not take place, certainly because NASA's excuse of not going back is they're trying to figure out a way to get the proper shielding and protection against the radiation so people don't die going past low Earth orbit, right? So you said something not too long ago where you said something along the lines of this information was hard to believe, right? It's hard to believe that maybe what you thought were real pictures actually aren't. Are you just kind of trying to process that? Are you coming into the realization that maybe what you thought you believed before was proof is not actually?
It says here that the last photo taken from above low Earth orbit was the pale blue dot, right? Taken in 1990, which would make more sense. Yeah.
So Voyager,
which isn't a manned spacecraft, so that makes a lot of sense.
No, it's an alleged space probe, which, if you believe it or not, is still up until, I don't know, when was the last transmission we allegedly got from Voyager? Within the past 5 years, I think. We're still allegedly receiving photographs from this alleged space probe that was sent into orbit.
I don't think we're receiving photographs, and I think we have since the ones. But
maybe it's Voyager 2 that's still providing images.
The last photo from Voyager was 1990, pale blue dot.
Okay.
Voyager
So
2.
take a look at the pale blue dot. What does that tell you?
What's that?
Does that give you any indication as to what you're even looking at in that picture? Have you seen the pale blue dot?
I don't think the quality of the image is very, I don't think it's like why does the quality of the image matter? Do you know what I mean?
No, like if I handed you a photo that looks similar to that, right? If not the exact same photo, and I drew a little arrow on it to one of the more lit places within that image, and I said, this is Alpha Centauri. would you just automatically believe that? If I drew the same arrow to the same pale blue dot and I said, this is Alpha Centauri, how would you know or verify, or what would give you any indication, even looking at that photograph, that that's Earth?
Well, I wouldn't see a reason for you to say that it's Alpha Centauri. And sure, if you did, you would try and make it a bit more believable by maybe putting some sparkles or something around it. Yeah?
I don't know if sparkles would make it more believable. It actually would make it look more fake. But either way, man, looking at this pale blue dot image, does that make you think that that's where you live? That that's a picture of where you live?
Yeah, I don't see why they wouldn't.
So what on Earth itself, aside from you believing pictures that are shown to you, which we've already proven, the main one you thought was proof of where you live and the shape of where you live, was a utter fabrication. So what on Earth here, the ground that you and I are both currently standing on, indicates that you live on a globe?
Because that has no reason. Like what? So, wait a minute. Say that again. Sorry, really, I'm tired.
Yeah. So what here on Earth gives you any indication, you personally, any feeling, any observation, or anything that you see in your daily life looking around you would give you any indication that you live on a ball?
Well,
that's spinning.
Nothing, but it's the same for the other way around. There's nothing that gives me an indication that it's flat as well, because it's quite hard to observe that.
Sure. I mean, I observe it all the time. I live near water, right? So I see very far. Looks very flat. When I go over, across this very large bridge in my area that's tall enough for cruise ships to get underneath it, and I look around, everything that I see around me indicates flatness. No indication of curvature at all whatsoever.
But can you see those ships forever? Like, can you see them go forever?
Forever? Do you think you can see forever?
Well, I'm sure the higher up you are, the further you can see.
Okay, so if I had a penny in my hand and I was standing on that ship, would you be able to see the penny?
Ships are quite large, and you can
How far away do you be able to? How far away do you think you'd be able to see a penny?
Oh, I don't know. About,
according to you, forever, right? Forever.
What?
If I just went straight up in the air, would you be able to see a penny that I was holding in my hand as I continued to increase in elevation forever?
If I had a telescope that could magnify it a significant amount.
Okay, so let's even say that the moon is as far away as they claim. Could you see a penny on the moon?
If I had a significant enough telescope, probably.
There's not a telescope good enough in the world to be able to see that.
What? Well, yeah, obviously.
So when the ships go off in the horizon, you don't have a telescope. You have your human eyes. With your human eyes, would you be able to see a penny on the moon?
Well, no.
Right, because you can't see forever.
It's different,
right?
Perspective.
You
things
understand that
things shrink.
Things get smaller with things shrink as they get further away.
There's a difference between a ship dipping under the horizon and something shrinking.
Yeah, can you explain to me the difference?
You can see the ship get lower, and if you go up, you see the ship again. If the penny was at the same distance, if the penny, that it doesn't matter how high in elevation you are, you'd still not be able to see the penny.
So as the ship moves away on the sea, wouldn't you expect it to get lower because it's getting smaller as it moves further away? Or Why
yes,
why
there
wouldn't
wasn't
that be your
any
expectation?
What? Sorry.
Why wouldn't
The
that
ship
be
is
your
getting smaller,
expectation?
but not a significant enough distance. It's not a significant enough distance for it to be any. I don't get what you're asking here. Sorry, it's quite late.
Okay.
Well, you say
Okay,
you
fair
should
point.
see ships go over the horizon, right?
Yes. Yes.
So ships get further away, they get smaller and harder to see. But there's also a ton of different things that take place in the atmosphere.
Yeah, so I have a question. I have a question because he's saying if things get lower in your field of view, I guess the insinuation is that they're going over a curve. So I'm in my house and my ceiling is getting lower. Is it going over a curve?
What do you mean?
Well, I'm looking at my house, and for some strange reason I just can't understand, rather than my ceiling being straight, it seems to be angled down in my field of view, as if it's going downwards. So I can't fathom it. I guess my house is built on a curve.
It could be. I don't understand the question. Like, is the
Yes, that's
ceiling
the
actually
point, my
curved?
friend. My friend, the statement's incoherent. I know that my ceiling is straight and flat because I can measure the entire thing. So I know that the effect of it going down is not because of anything physical. It's all to do with optics. So why would you just
So
jump to the assumption that if I can't see something or if something is appearing to go down, that it must be because of a curved earth?
But don't you? I mean, I've never seen my ceiling curve, so I don't like.
Right, but you have seen your ceiling recede in your field of view on the y-axis, yes or no?
Can you word that a bit more?
Let me give you
I don't
a
understand. I'm
visual
not
here that
smart.
Yeah, visual
yeah,
aid.
let me give you a visual you might comprehend. So let's say have you ever been to a hotel?
Mhm. Yeah.
Okay. So imagine a hotel with a very long hallway, right? We know it's flat, straight, because they don't build buildings that aren't straight, right? So we're looking down this long hallway and there's lights on the ceiling.
Yep.
When you look down that hallway, does the floor appear to ramp up towards your eye level? And does the ceiling appear to ramp downwards towards your eye level as it gets further away?
Yeah, to a point.
Yeah. So in reality, is that ceiling that's above you physically going downward? Or is it just a matter of your perception due to perspective?
No, but I don't think that's a large enough scale to see. Like the hallway would have to be quite long, wouldn't it?
Wouldn't even have to be that long.
Uh,
I mean, that's what you
to be able to
see.
see it. Well, yeah,
Yeah.
yes, because
Have you ever been in a hallway where you don't see the ceiling appear to come towards your center view and the floor appear to go up towards your center view? That's how you view everything. Always. It's perspective.
Well, I don't think there'd be a hallway long enough to show it not. You know what I mean? Like, unless the hallway is like, so if you had a hallway that was from where you are standing to the ship that could be really far. I don't know how far ships are bend across the horizon. I'm not sure about that.
Dude, if you had a hallway, so let's talk about that. If you had a hallway, if you look at the live stream voice text, you'll see an image of a hallway that's running as a GIF, and you'll see the effect in question. Okay, so if you had a hallway, the length all the way out to a ship where a ship starts to disappear, which is roughly 3 miles, 3 to 4 for a 6-foot tall observer if he was on the shoreline. If you were looking down that hallway, right, after a short while, the rest of the hallway would be unresolvable. And all you just see is everything converging to a point, and you'd be impossible to see the rest of the hallway.
I agree with that. But a
Right.
ship.
So if you then remove the hallway,
Mhm.
does the same angles of light not apply anymore?
The ship isn't the same as a hallway because
Why not?
the ship is a point, if you know what I mean.
Right. So remember
I
what
don't
I
know
just
if you
said.
get what I mean.
Remember what I just said. The angles of propagation within the hallway and the angles that they enter your eye or the optic, right, are at too small of an angle to be resolvable on the hallway, which is approximately the same height as a person, right? And all of the information from the end of the hallway recedes into a point. So if you then remove the hallway, would not the same thing be happening to the portion of the ship that occupies the same space as the hallway, being approximately 7 to 8 feet tall, standard hallway? So at
Isn't a ship bigger?
3 miles, I'm talking about the portion that represents the same scale as the hallway, like I just said. 6 to 8 feet.
But how am I supposed to see that point from a ship that's far away? I wouldn't be able to see that.
You got it.
I
So
wouldn't be
what
able
you
to
would
see
what you would see by what you just admitted is you wouldn't see the portion of the ship that represents the same scale as the hallway, but you would see the portion of the ship that is much bigger, being the top. So by your own admission, you generally conceded that the bottom of the ship would disappear due to the laws of perspective alone.
the point of the ship that faces. You know what I mean? Like the point of the ship that is level with me.
Right. That part's
Because
going to disappear
obviously,
first.
the whole length of the ship isn't the same size as
but
the
think,
hallway.
think about this. Think
Stop
about this.
there
The
for a second.
ground.
Hold on. Stop there. Stop there real quick. Because he's saying something that most climbers don't get, and that it's worth noting. Okay, the whole ship represents a certain angular size, but each portion of the ship represents a different angular size. And the smaller portion at the bottom of the ship subtends a different angle than the whole ship. And due to the law of triangles, that angle is going to be smaller. And since we see in angles, once the angle gets too small, we won't be able to resolve the bottom of the ship while still being able to resolve the top. Thank you for being one of the first people to get that without having to go for 2 hours. All right, I yield the floor.
Yeah, that was a really good point. Just think about it for a minute. If the floor all the way up to the vanishing point, and at the vanishing point, that's where you can't discern the floor anymore. Of course, his feet or the bottom of the ship at that point cannot also be discerned when it's connected to that point on the floor. Do you get that?
Oh, wait, so you're trying to say that it's like a plane? Like, I don't know if so every part, so right, so every part is the. Sorry, I'm a bit, I understand what you mean, but every part of the ship. Sorry about this. Can you just
Yeah, so
say it?
think of it this way. If you had a smaller ship, like a dinghy, just a little boat, that was tied to the side of that ship as it goes away so that you can see it. And you see this little ship. Now, if you removed the big ship, you understand that that smaller ship is going to visually disappear at a shorter distance than that large ship because it's a smaller object, right?
Got less height.
Yes, less height. So you would expect the little dinghy to disappear before the large ship, solely just based off of its height, right? Because you understand perspective works. The angle is going to be too small for you to resolve that small ship first. Now imagine tying that dinghy to the large ship and sending it out. It would stand to reason that that small ship is still going to be unresolvable at the same distance, regardless of whether it's tied to the ship or not tied to the ship, right?
Agreed.
So as that little dinghy disappears because we can no longer see it due to angular resolution limits of our eye, it's tied to the ship. Wouldn't it stand to reason that the whole entire portion of the ship that is that height would also be unresolvable?
Yes, because in my opinion, it's gone under the horizon, but I understand what you said.
Okay, perfect. So your claim would then be that the only reason that things disappear from view is because they're being physically obstructed by Earth curve. Would you agree with that?
Yes, on long enough distances.
Okay, perfect. So now I do this on the regular. I go to my little lake, 333 meters across from the observation point to the observation, which is a yellow floaty boaty on the other side. Okay. Now you put that into the mass of the alleged curvature of the Earth, and you will find that the heights that I observed at, there is no way that the Earth curve, if it existed at all, could be precluding that boat in totality. Okay. So this means that it's not geometrically possible for the curve of the Earth to obstruct that boat. Yet, okay, 9 out of 10 times I go, pretty much consistently, the entire yellow boat disappears. So, my friend, what is causing that to happen?
Sorry, so it's 333 meters, right?
Mhm.
How big is the boat?
About
How
half a
tall
meter,
is the boat?
1.5 feet. It's about 1.5 feet tall.
Okay, well, let me do some maths. So how many? Sorry about this.
Just doing the math up the
Sorry
top
about
of my
this.
head, AI, no portion of that boat should be hidden. And if it is a portion, it's such a small portion that you wouldn't be able to notice based on the Earth curve calculator. Because that's what, about a quarter mile?
Right.
It's 1.2 miles. No, sorry,
No.
0.2 miles.
Quarter of a mile.
Yeah, 0.2 miles. Sorry. All right, so
So
then that would be.
do you know what the alleged
8
drop
mile.
over 8 inches per mile squared, right?
Yeah.
Right. So
Yeah,
that would be
so-
at the surface.
So then it would be like 1.6.
1.6 what, inches? Would be
probably,
the
yeah.
alleged hidden height due to the curvature of the Earth, allegedly.
Mhm.
So when AI said he goes out, and 9 times out of 10, the whole entire boat disappears. Why? Is that Earth curvature? Do we have a tiny Earth? Smaller Earth?
That'd be funny. Probably not.
I'm so glad you said that.
There's no reason.
Right. So then
no
what
reason.
must be the reason? Okay. So it looks like it's happening. So what must be the reason?
The only other hypothesis you've given is that whole stuff about vanishing points.
Well, let's just be more broad, just for fairness sake. Okay. It's not because of geometry. It's because of an optical effect of some kind, whatever that might be. It's no longer in the category of geometry. It's in the category of optics, correct?
Yes.
Exactly. So now that we've agreed that the bottom of things can be missing, or an entire object itself can be obstructed without the necessity of Earth curvature in the way, we can now make progress.
Oh, sorry, I'm sorry, it's really late here.
Now,
I'm
I
sorry,
want you to realize that that's a necessary concession that you made because it's obvious, because it's observable, that it is not true that the only way for things to disappear from the bottom is because of Earth curvature. So that's a false statement.
You've proven that to me.
Yeah, I just did, and you conceded. So if you retract now, it just means, right, yeah, you're fair, exactly. Now, you might argue that those effects are this or those effects are that, but we know for certain that it falls in the category of optical effects. So now, since we can't do this for real right now, we're going to do this in our minds, right?
Okay.
And mental experiment, okay? So, well, first let's preface this. Do you know that the optical device, whether it be biological or synthetic, has a limit to it, known as the angular resolution limit? Everything that has an angular field of view has this limit. It's just that simple. It's a hard physical limit. It's known as the Rayleigh criterion.
I heard of it.
Yep, it's known as the Rayleigh
definitely heard of that
criterion.
before, but like,
So for the human eye, it's approximately 0.02 degrees. Okay, what that means is that any light from the source that enters below that limit will be interfered with by any other light that enters within that angle. And therefore there will be no resolvable information, and it can at best be only rendered as essentially, for lack of a better term, 1 pixel value.
isn't
So
that
you imagine,
resolution?
yeah, 1 pixel value, meaning one element, right? One element of the total picture that you're seeing.
But
so in that area,
everything have different
in that
resolution.
angular area,
Sorry.
no. This is angular resolution, not pixel density. So for example, if you only had 4 pixels in your sensor, right?
Mhm.
If you literally had only 4 pixels in your sensor, you could never render something that requires 10 pixels to render, correct? It would look like blurry nonsense, would it not?
Yeah.
Exactly. So now you fully understand the principle. So if you imagine a man standing on a line looking out, right? And these radials, right, of angles emanating from his eyeball, you can imagine the 0.02 degree triangle coming out from his eye and going out along the horizontal line in front of him until it intersects the horizontal line. And so you have a triangle, right? And I want you in your mind to color that triangle red. Now, everything that enters that triangle must, of a necessity, render as 1 color value in the final image, which we've already agreed. It just so happens that if you take the time right now to map this out, it pretty much coincides with where the alleged horizon is for a 6-foot tall observer. The triangle hits the horizontal line approximately at the same distance. Very coincidental, don't you think? So principally, we know this to be true. So for example, let's say that you're standing over water and then you have a brick, but it's not a solid brick, it's a floaty brick. And let's just make it red, because red is very bright, easy to tell apart from blue. So if you take said brick, and we've already established that this water is horizontal, okay, it's not curving in any way, it's perfectly horizontal. That's the premise. You might even imagine that it's a floor, painted blue rather than water, make it easier. So you take said red brick, put it on the floor, and you have your friend start to walk away from you. Now, as he keeps walking away from you, something interesting is going to happen. Eventually, you will not be able to see the color red anymore, because the red and the blue simultaneously will occupy less than 0.02 degrees. And as they approach that towards 0 degrees, the blue and the red will meld together into purple. And then it will meld together to where you only see the air and the blue floor, and you can't even tell the purple anymore. Now,
That makes sense.
let's just say, for example, that you call your friend, you say, okay, I can't really see the red thing anymore. So you can stop pulling. And your friend goes, okay. And he stops pulling. Now what your friend does is he calls his other friend who brings over a truck full of red bricks. And he starts stacking the bricks on top of the previous brick that you can't see. He stacks 1. You start to see a very faint purple. He stacks 2. The purple intensifies. He stacks 3. You start to scratch your head and say, I'm starting to see red. He stacks 4. Now you see some more red. He stacks 5, 6, 7, 8, 9, 10. And now you see a line of red. But when your eyes trace down this line, as they get closer and closer to the floor, eventually you cannot see the bottom of the stack. It has become unresolvable. It has disappeared. Rest assured it is there, and it is the bottom portion of the stack. But the stack in total has disappeared from the bottom, has it not?
I like that. I do like that, yeah. I
Now,
really do
this
like
is a
that.
necessary, yeah, you're right. And this is a necessary consequence of the way our eyes work. And and all optics with an angular field of view, by the way. In order to see without perspective, truly, you need to have a lens the exact size with all available propagation angles to a parallel rate to the target source from the object. So if you want to observe a 100-meter building, you need a 100-meter lens, not an angular lens, but a straight lens that only allows the light to pass collimated, parallel, and horizontal to the sensor. So you need a 100-story tall sensor and a 100-story tall collimated lens. Okay, these types of optics don't exist. So every observation that we make is through an angular field of view with these limitations, in which we already have said that because of optical phenomenon, the bottoms of things can disappear. And that's just the facts. All right, so with that, I rest my case on that, unless you have any questions specifically.
Why would you need a 100-meter lens to see a 100-meter thing?
You need a 100-meter lens to see a 100-meter tall building without the effective perspective, and it needs to be a collimated lens where the sensor exists parallel to the light coming from the object.
Oh, like a mirror.
So if you don't have such a lens and you use normal lenses like your eyes, you'd be standing on the ground, right? And the angles of propagation from the top of the building would be at a downward angle towards you, forcing all of the light from the propagation angles to enter at essentially inverse angles after they pass the lens. And that's what creates the effect of perspective, is that you see an
Imagine
angle.
like a mirror. Oh, this is right.
What's
I'm
that?
imagining like a mirror, right? Okay. And this mirror is the same height as something. Yeah, right? So it's like a mirror, if you know what I mean. It would work like a mirror.
Yeah, well, the problem is that mirrors suffer from a perspective as well. If you stand in front of a mirror and start to walk away from it, does the image that appears to be you not shrink in size? Of course it does.
Yeah, because that's your eyes. It's not the mirror.
Right, because your eyes are getting the angled light, not the straight light, not the direct one-for-one parallel reflection that's going back in on itself. So now you get it.
Mm-hmm.
There's also another way
Yeah.
to show it. The ancient Greeks, of course, didn't have any fantastic telescopes or anything. They just looked at the horizon with their eyes, and they drew on a piece of paper and used orthographic view to assume that the horizon was Earth curve. So in orthographic view, things don't get smaller with distance. So the mountain is just as tall angularly in their idea, in their math, but that's not how it is in reality, it's actually tiny in reality. And so when they compare these pictures from reality to their math or orthographic side view, which they got from the Greeks, they're actually just taking perspective and turning it into Earth curve and assuming that the horizon is this start of this Earth curve. But there's no evidence to actually substantiate that.
So with telescopes, you have a more resolute lens, not lens. You know what I mean?
Yeah, with a bigger aperture, you can see further, like in the black swan images and other such things. That's why we use telescopes, to see further. And then if you use a very small aperture, like we did with the pond tests and other stuff, such things, we can see that the horizon appears much closer and things disappear over what should be a flat surface. According to the globe mechanics, these bodies of water should not have enough convexity to hide these objects, but it does happen on the smaller aperture cameras. But on the bigger cameras, you can actually see the boat still. So it is optical. There's no Earth curve here.
What's black swan? Like, I know what a black swan is, but what is black swan experiment?
A black swan is not an experiment. It's a reference to the Karl Popper's falsification, and he has a story that goes with it. You can say that all swans are white, and people can just accept that. But if you find a black swan, you know that all swans are white is just wrong. There are black swans. So that's what we find. We find black swans that show that all swans are not white. And so the black swan image is just what this image was called. It's two oil rigs taken. A snapshot taken from a video where he lowers the camera 1 foot off the surface of the water. So the horizon should be only 1.22 miles away on the globe, but we can see the horizon way past the second oil rig. So that's over 10 miles. The size of that globe is completely unsustainable, so it just doesn't work.
Black Swan. Excellently
Yeah, so it's
well
like,
said, Drace. Go ahead.
so it's basically just a proof, a contradiction. That
Yeah,
makes sense. I like that.
we're comparing the claimed globe geometry to reality, and it doesn't hold up. But you can
I'm
go
gonna
check
start
this
saying
out. You
that.
don't have to just believe anybody here. You really should go out and see if you can test some of this stuff on your own. If you have a body of water nearby that's like 5 miles, 10 miles big, maybe bigger, that's a good start. Next time you go on vacation to the beach or something, take an Earth curve calculator with you. See if you can do some long distance observations. This is the kind of stuff you don't want to just leave this Discord and be like, well, these guys on Discord told me it was flat. Like, you want to go out and check for yourself. So, there's plenty of resources for you to be able to go out and do that. And if you need help, we're here.
Okay, so let's establish where we've come from so far. We've conceded that the concept that the Earth curve is the only reason why things disappear from the bottom up is false. Right? Now we've been presented with the black swan, which is a premise, right? In a sense. That premise is that if you can disprove a certain proposition by providing one counterexample, that negates the proposition and the proposition isn't true. So the proposition in the idea that we already agreed to isn't true is that the horizon is a hump of Earth curvature between point A and B that's blocking the bottoms of things. Now, we've already agreed together that that's not the case. Now, let's talk about the black swan. In the black swan photo, the horizon, as you can clearly see by looking at the photo, is beyond the oil rigs, right?
Mm-hmm.
The oil rigs are at 9 miles, respectively, between the other one and the other one. There's approximately 9 to 10 miles from the shore. This means that the horizon is greater than 10 miles. We only know this because we see the boats. Sorry, not the boats, the oil rigs. So we know the horizon is beyond 10 miles. And as he said before, it must be, if the Earth is a globe and if the horizon is a geometric hump of Earth water, right, that's curving and getting in the way. From the observation height that the man observed this, it should have been at 1.225 miles. It's not at 1.225 miles. So the necessary conclusion is that the horizon that you see is an optical phenomenon, not a geometric edge of Earth hump curved water. Now, in summation of all of this that we've already discussed and you conceded to, okay, is that there is no hump of Earth curved water blocking the bottoms of things. Now you might say, okay, that's compelling. How would I know for sure? Well, the correct answer is to directly measure the water. So far, we've been talking about optical defects, right?
Mm-hmm.
So let's measure the water. How are we going to do it? We can't use a string because of the catenary curve problem, right? Which is a physics problem. Just take my word for it. Can't use a string.
Oh, okay.
Can't use a solid piece of steel for similar reasons. So the most efficient means to get something at that range, that we need a sufficient sample size, right? So what's a sufficient sample size? Let's say 25 miles. That sounds pretty good, don't you think?
25 miles, you'd see, doing the maths. 25 times 8, 200 inches, which is what? I don't know what that is in feet.
25 miles, it would not be 200 inches.
Wait, what? So wouldn't it be 25, then 8 inches per mile, times it by 8?
It's squared.
Oh, there we go. So would it
Okay,
be
if you were doing
5?
it your way, it'd be a
5
slope,
times.
not a curve.
Oh, yeah, that makes sense. Sorry. Right, so 5 times. What is it again? What is it? 5 times 8?
It's 20,
40.
no, 25 times 25
Uh-huh.
times 8
Right,
inches.
so
That'll give you inches.
sure.
5,000
And that's
and
going to
divide that
give
by
you,
12.
right, that's going to give you the drop.
416 feet.
Right, so that's 416 feet drop, right?
That doesn't seem very believable to me. I'm gonna be honest.
Really?
Yeah.
Why not?
I don't know. I don't think you can see 400 feet of drop between 25 miles. That's like
I mean, that's the math of the ball.
significant. That's very
Yeah,
significant.
it's
You know
very
what I mean?
significant. So we have
yeah,
something that's 400 feet, right?
Like,
400
I
feet.
can live with like 400 inches, but I can't live with 400 feet.
Well,
Because
too
that's like,
bad, because that's the measurements of the
what?
ball that they told you exists.
yeah.
Okay, so
So
I'm going to walk you through it. So this is how it goes. You got 400 feet. It's actually worse than that, but we'll just use 400 for sake of argument. It's easy to divide. So what they did is they went, set up what's known as a laser transit measurement. Laser transit is basically a really long level, right? Because obviously you don't have a 25-mile long level. So you level the laser on the one side of the land, you shoot it over 25 miles of water, and you have a target, right? You set up the laser at 6 feet off the ground. You set up the target at 6 feet off the ground. Right?
It's kind of laser be refracted and stuff though.
Ding, ding, ding. He said it. He said the word.
Oh, what? Hey. Shh. Calm down.
Oh
Okay.
no.
We're not getting frenetic here. Yes. The correct answer is lasers can deviate due to refraction. Okay. So I want to ask you this before we start. You already have heard this is a 400-foot differential, right? Between the drop.
Mm-hmm.
Now,
Yeah.
we're going to measure this. We're going to measure this to see if that drop is there by setting up a laser transit level. Now, I'm going to continue with how this works, okay? So we'll set a baseline for how this thing is supposed to function. So in construction, let's say you have a foundation, so you have a piece of land. You set up the laser on one side, you set up the storyboard on the other, which is what the laser hits, and it tells you the differential between a level laser and the ground. So for example, if I set up my laser at 4 feet tall and the storyboard says 6 feet, right? Then that means I have to add some dirt to level the ground, right? And transversely, if it says in the other direction, I have to take some dirt away. So what this tells me is over my foundation that I'm trying to lay, whether or not I'm laying it flat. Because I can go with that storyboard and get 4 feet here, 4 feet here, 4 feet here, 4.5. Uh-oh, I got to change something, right?
Yep.
Now, of course, there's tolerances, right? So when, for a client, I want to make a level floor or a level foundation or a level piece of land, there's tolerances that they're willing to accept. Now, dirt has a different tolerance that someone's willing to accept in concrete, has a different tolerance that someone's willing to accept for their tile in their kitchen floor, right? They want that floor flat. They don't want it curved, they want it flat. So I want to ask you this question. If they hired me to make a flat floor, and I got my measurements so off that I was 2 orders of magnitude off level, is that acceptable?
No,
it isn't, is it? In fact, 1 order of magnitude is not acceptable. So for example, if the differential is supposed to be 0.4 and I have 0.40, right? Those are the same, are they not?
Yeah.
Okay, but what if I have 4? I'm off by 4.
Yeah.
That is not a flat floor anymore, is it?
No, it's what's the word? Sloped.
Right. I've done screwed up. Now, what if it's off by 40?
Whoa.
Yeah, you wouldn't even be able to walk. It'd be so steep. Right? So not acceptable. Okay, so if we take this laser transit and we want to know whether this Earth curve hump is there, and we can measure by getting the laser to hit a target of equal height, and it's off by 2 orders of magnitude, we've already agreed that that's not acceptable. So if the laser is at 6 feet, right, which is in the single digits, then the double digits, right, the tens is not acceptable. And the hundreds is definitely not acceptable, correct? So lo and behold,
that would be a slope.
Lo and behold, this test was conducted. The ambient conditions were measured. The refraction was taken into account. The millirad beam divergence for the laser in question that was used on this day was taken into account. The laser hit the target. with a maximum differential of approximately 3 feet, still within the single digits. And they're supposed to be 400 feet. So
That's
if the
acceptable.
Earth was a globe, the laser would have went over the target by hundreds of feet upon hundreds of feet. Yet the laser hit the target. So by the principle of laser transit within the margins of error, that surface is flat.
Oh,
Now, what say you should be, oh, I'd like to see that evidence. Lo and behold, we have it for you. We have a documentary of the people doing it. We have a short version of it if you don't want to watch the long version, just to get your, appetite satiated. We have a document, 120 pages, with all the information, the sites, the equipment, everything.
oh,
One of my good friends will post that for you.
Friends?
Yeah.
There we go.
My buddies. So what's going to happen is you're going to say, oh, okay. Right? And then you're going to be like, well, is this the only test that's been done? The answer is no. Many have been done. Many, hundreds. With all different kinds of methodologies, all demonstrating no big hump of Earth curve in the way. Observations as well, in excess of 255 miles, to which the target object should not only be 400 feet below the curve, but should be a mile below the curve. Yet the object in question is clearly visible. So we've already established within tolerances that the Earth doesn't measure to be a ball, that the horizon that's been claimed to be a horizon doesn't exist, and that it's not true that the bottoms of things can only be obstructed or cut off by Earth curvature. So we've basically shown that there's just no evidence or need for this Earth curvature.
What? Wait a minute, I'm looking at this thing, right? What is this thing about a blue laser and a green laser?
Blue and green lasers refract at different rates. Colors refract differently comparative to the refractive index of the medium. By using different colored lasers, you can determine the refraction that's present in the ambient conditions.
Okay.
Which, by the way, the military, recently did that. The military recently did that at 120 kilometers, shooting 2 lasers to see how it does, and they found out that it doesn't match the globe model.
Space Force is going to be angry about that. Space Force is going to be angry at that.
Well, I mean, yes and no, because most people, when presented with this evidence, just hand-wave dismiss it. Because they're under the impression, right, that the Earth is a ball. Therefore, what must be happening is that light is curving. Do they have any demonstrable evidence of such a thing? No, it's just an affirming the consequent formal logical fallacy. So now we've established that the rebuttal for all this evidence you've been presented with is a logical fallacy, not actual measurements or demonstration. So again, we just have no need or demonstration of this Earth curve on the ground level. So if you have direct evidence of Earth curve measurements, that is what is necessary to rebut these points.
That makes sense.
Unless you have that, the proposition stands. And the reason why it stands is because we all experience the Earth as flat, stationary. That's agreed upon by both camps, by flat earthers and globe earthers alike, that our present day experience of the Earth is a flat, stationary plane. That's how we experience it. That's the base axiom of our human interaction and experience.
Yep.
And based on everything I just said, that coincides with that experience. The globe curvature is an extraordinary claim that requires extraordinary evidence. But most people are fooled by the claim that a fuzzy dot on a piece of paper is a picture of the Earth from space. Given to you by a government, no less, who we know lies on the regular.
Alright, I'm just interested, right? Why would they like, so now you're gonna have a really good answer this. Why would they lie?
Why would they lie? There it is. There's the $1 million question, isn't it? Who cares why they lied? Don't matter.
Right. But you're an
Yeah,
intelligent person, right? You'd lied before and you've been lied to before. So you know why people lie. You already know the answer. You don't know the exact specific answer, but you know the general answers. To gain power, to gain resources, to gain fame, to gain women, all kinds of things people lie for.
the government doesn't gain anything from anything
So
like
says
that
you.
from that though.
Really? So
It doesn't
if I can
gain
post you,
power.
okay, cool story. Cool
Doesn't
story.
gain prestige. It doesn't
You sure about
gain
that? You sure about that?
money. It doesn't. Yeah, quite.
Really? So, okay, so let me ask you this question. Why does North Korea lie to its people about the status of its weapon systems? Why did Iraq, when I was there, lie to its people about the capacities of the US forces? Why did the
Make them
United States
seem
government, during the space race, have a vested interest to lie to the people that the United States was the first to conquer the moon? And you're trying to tell me that there's no prestige or power or world presence to be gained from a proposition that you've conquered space?
Yeah, because they just wouldn't make the claim that they could go to the moon in the first place. It would be
Right.
better
So
for them to just
you're
not make that
now
claim in the first
fair.
place.
So let's talk about it then, and let's reason with a real tangible reason why they might lie about such a proposition. So, as a student of history, which you are, clearly a scholar, who have been through standard school and have been taught the history of the expansion of the Western world, that people found out that there was more land. And what did they do? They left their states that they were involved with to pioneer the new land. So we've already experienced in our history a time when new land was told to be given and people uprooted themselves from their governments, even had revolutionary wars against their governments in order to create new territories and new civilizations. So if the Earth is not a globe, then that means that the boundaries are unknown. And that means that there possibly could be more land. Now that, my friend, is a very good reason to lie.
But aren't they also saying there's more land to go to if you can go to the moon?
Yes, but think about this, my friend. To get to new land that's connected by water, you need a boat that you can literally build yourself. To get to space is unreachable. Now you might say, oh no, it's totally reachable. No, it's unreachable.
But
the elite, the very small percentage of the elite, even alleged to have gone to space.
Yeah, just
So
think
let's be
about
clear,
it.
we're only entertaining this just to give you a satisfaction because we've already demonstrated in spade that it's obvious that they lied, and why they did is highly irrelevant. So I yield the floor to my friend
yeah,
Drace.
Yeah, I just wanted to say, just think about it. Richard Branson and Jeff Bezos have all the money in the world, but they could not go high enough to go above the clouds. So they were just still in the air, and they never went to space. So even with all of their money and power and influence, you can't go there.
Well, where is this other land? Because everyone sailed to every part of the ocean. So if you say there's, like past Antarctica, you've also said that it's really hard to reach there. Like, so what? How could an ordinary person ever expect to cross Antarctica?
Oh, there's more than that. When you think about the globe and you try to unpack it, there could be more lands on and within the area heated up by the sun that is still hidden due to the way they map the globe. So we don't know the full extent of our world, and we're limited how far we can actually explore south due to the Antarctic Treaty. So we can't sail all those seas, and even just sailing willy-nilly, the coast guards of the specific countries will contact you and escort you back if you're sailing somewhere you're not allowed to sail.
What? You can sail wherever you want, as long as it isn't in the nation's waters.
What are you talking
Right?
about, dude?
You can't go to the middle. You can't go to the edge. That's a fact. You can't go to the middle. You can't go to the extreme edges either. You will be brought back.
Because of ice.
So if your proposition is true, my friend, that you can, then that means that there would never exist a story of a sailor freely roaming who was turned around by any military or shot at, correct?
No, because that would probably be in the nation's waters, or they were doing something illegal.
Right. So there's a guy called Jarl Anderhoy, right? Who tried to go to
Never.
Antarctica in different manners. Okay, he lost a crewman being shot at by the government. So it's not the case that you can just go where you want, especially in regards to Antarctica. Not only that, but the logistics of doing so is very hard because of the nature of the temperatures and all of that. But again, keep in mind, we're only entertaining this for your satisfaction because we already understand logically why someone would lie is irrelevant. That they lied is the matter of the day. So you're just to be fair, I'm no disrespect to you. You're trying to think these things through to make peace with it. But the problem is that you've already arrived at the bargaining stage. So your brain is already processing this information.
Guilt. Was it the 7 stage, right? Yeah, but
yes, for example, my grandfather's is dead. Why would he die? Why would God do such a thing? It's like, he's dead. It's just a simple fact. He's dead. So now you have to go through that process of trying to understand why and come to peace with the reason that you may never know. Once you accept that you may never know, then you can have peace with the fact that the lie is just a lie.
I don't think it's possible to patrol that big of an area, though.
Can I just say this, though, real quick? Like, have you been living under a rock for the last, 2-3 years, dude? Well, I don't know where people get this idea that you can just go wherever you want. You can't even fly a drone wherever you want. They have perms and rules and stuff like that, man. I mean, you can't even get in a car and just go wherever you want. You can't walk wherever you want. So why can you get in a boat and go wherever you want? Why can you get in a plane? You can't. I just think it's goofy that people have this idea that you have. But then again, look at the last 3 years. You couldn't even go to the grocery store, dude. That's like, dude, I just don't know where people get this idea that, oh no, you could just do whatever you want. Like, no, you can't.
Because it's a big place.
Okay, and
I don't think it'd be possible, even if
last year
everyone
you
was on board
couldn't
with
go
it.
to the grocery store.
Everyone knows where that is.
Come on, dude.
Oh, so you're trying to say that you could do it? You could do it because there's nobody there to monitor you because it's so big they couldn't possibly know what you're doing. Is that
It's
your
like
claim?
saying I can just do whatever I want on the highway. Who's gonna catch me?
Yeah, so they don't have radar anymore or
Come
anything like that. They don't track ships now.
If you were on Antarctica, no. What?
That's like saying, like, dude, well, if I'm in the boonies, who's gonna catch me? I'll just do whatever I want. I'll just drive as fast as I want on this highway. No one's gonna get. Who's gonna get me?
So guess how they caught Mr. Yarrow? Information that was acquired at land, because you have to plan and do all the logistics at land before you depart. It's like you don't just magically arrive in the middle of an ocean where there's nobody there to catch you.
You can get a boat. Like, there's nothing stopping you from getting a boat and then going and sailing. Illegally, as you're saying. And, going there. Like.
Dude, you know what,
You
dude?
get me?
To be fair, guys make excuses about all the logistics of how their girlfriend isn't cheating on them. Because why would she? There's no way a car can go from here to there with that much gas. Of course, somebody would have noticed she was at the store, and all these excuses upon excuses upon excuses because they don't want to accept that one of their friends gave them the stone cold brass tacks truth of what their girlfriend was up to the other day.
But why would she lie? There's no way she.
And you may die. You may die without her ever telling you the reason.
Reporting back in after sunset here, great looking sky. You can see the tail end of the Big Dipper.
Ooh.
And is one of you using some kind of machine tool, like a drill motor or anything like that? No?
Yeah, I'm doing my own teeth.
No, seriously, I'm asking a serious question. No one's using anything? Because I thought for sure that I was approached by, this is going to sound strange, by a mechanical dog.
What?
I thought it was a drone at first.
I mean, that's a thing now, so,
Could be.
But wait a minute. Whenever one of you opens your mic, it sounds like that. So I'm going to leave it to say the most logical thing is to say that it sounds coming from the Discord. And it's my imagination. I just heard it from the Discord. So good. Got that solved. Thanks for your help.
Was it me,
It
Sonny?
wasn't a robot dog. Yeah, I'm glad it wasn't a robot dog. That would have freaked the shit out of me, but that's okay. I've fucking fought him off if it was.
I just turned my headphones off, Sonny. Was it me?
I really don't know exactly. Try to talk. Let me hear.
You sound like you're on some headphones.
You listen. You two guys can solve that in another room. We're going to continue with the conversation.
All right, my bad.
Right.
Exactly. Let's continue with the conversation. Forget about it.
So if you knew that your girlfriend cheated, right, and you couldn't figure out why, and to her dying day, she never told you, does that mean she didn't do it?
Correct. Yeah. I mean, if you don't know why she would have, that means that she didn't.
And to be fair, it may give you peace to find out the reason, right? And that might be why you want to know, because you want to have some kind of peace with why the powers that be who know the truth are lying to the public. And rest assured, it's a very small amount. Most people just believe what they're told and raised in by school. They have no clue about the true nature of the world. They're just Muppet puppets that watch the news and believe what they see, right? If they're shown a photograph that's allegedly to be a photograph, they're just going to say, yep, must be true.
Well, couldn't they say that the excuse that they give, that could also be a lie?
Yeah, I actually heard in the background that it was some kind of Dremel tool. I'm going through my files now to find out which model based on the frequency. I'll get back to you on that.
It's also, worst part is, we kind of showed him a video of the guy who shared it with us, sleeping with his girlfriend, and he's still like, why would she lie about it? It can't have happened. Why would she lie? There's no reason for her to lie, so she probably didn't do it.
There's no way she could possibly have done it. I can't think of a good reason why she would have done this, so then therefore she did not. Glober logic.
Nobody admitted to using a drill motor or Dremel, so therefore it could not have been a drill motor or Dremel.
Right, that's false. Sounds retarded. Yeah, so let's say for example that we know, or that you know. All right, let's say for example that you know that not only have you been presented with recent evidence that your girlfriend's lying, but in the past she's lied to you. Like at one time she said there's weapons of mass destruction in the closet. At another time she said, no, I totally didn't give those black guys syphilis. At another time she says, oh no, that's totally the reason why we went to war with Vietnam. Right? So the powers that be at the elite level have a track record of lying to the public. Right? So they're untrustworthy in a general sense. So they need specific evidence.
Wait, hold on a second there, because like Santa Claus, when it brings joy, then it's not a lie. So it's okay to tell a lie as long as it brings joy, like Santa Claus.
Oh, I understand now. So if they have a good enough reason to lie, then it's okay. I get it.
Yeah, and then it's not even at that point. It's not even a lie at that point.
So what you're trying to say is S&M, sadist and masochistic.
Yeah.
I get it. Okay.
Mm-hmm.
Okay. Awesome. That's kind of like Christmas. Yeah. Oh, just like it. Oh, holy mackerel.
Yeah.
Yes. Like,
it's okay to
for
lie
example,
as long as it brings joy.
Yeah. For example, in this context, if the Earth was flat, that would have huge philosophical implications. A lot of the scientists who came up with these ideas in the past, who philosophically chose to disregard the Earth as having a central position in the cosmos for philosophical reasons, would cry at night. Therefore, we must continue this lie. And then you're like, oh, that's such a good reason. We wouldn't want the scientists to be scared.
Wow.